can hear. Yeah.
Okay. On behalf of the Faculty of Information Technology from Tôn Đức Thắng University, Vietnam, we are thank you. We thank you very much, Professor Vinod Nageswaran, to give us, I think, the interesting lectures. So, Vinod is a senior data engineering leader in many fields. So I think it's better if you can introduce yourself in detail for everyone. So could you say your slide now? Okay, thank you very much for give us a chance to hear a lecture from you. Thank you very much.
Sure. Thanks for the opportunity, Professor Kong. Can I start with the slide and then I can go on with my introduction part?
Yes.
Thank you. Um, uh, Good morning, everyone. I am Vinod Mageshwaran. I have 16 plus years of experience in data warehousing and data engineering and AI and ML work items. I worked on various ML projects. Right now, I'm working as a senior data engineer leader with Business Insider, or online publication company, where I'm helping my organization to develop AI products on various RAG application. So thanks for the opportunity, Professor, for helping a student to share my knowledge and get themselves onboarded with the RAG application. Yeah. So today the what we're going to discuss about is build a retrieval augmented generation based LLM assistant. So basically, at the end of the session, you would be able to develop your own LLM assistant using a Snowflake, and I'm going to provide you the entire end-to-end code, which is already available in the website. Okay. Let me start with the agenda. So to get to work on the LLM product, you have to really know about the RAG architecture. You really have to know what is LLM is. Then I'm going to start with what is LLM. Then I'm going to talk about why RAG, and then quick introduction about the vector database, which is really must for any kind of AI application. Then prompt engineering. Then I'm going to show you the live demo on how can you use all this component and build the LLM assistant using RAG application. Okay. Introduction to LLM. So by this time, most of you guys should be already aware what is LLM is. LLM is a large language model. LLMs are just an AI model designed to understand what a human speak in the natural language. And it is trained with a vast amount of text data to generate response on a complete text or answer any kind of questions in the real world. Example, most of you guys should already know ChatGPT, Bread, T5, Claude, and now with every cloud provider have some kind of a LLM model already available. So basically, it helps to generate the next sequence of the word by using the trained data. How LLM works? LLMs are based on a neural network that learns the pattern in a language. It can learn any language, just not the English. That's not the any of the regional language or a local language. It can be trained to learn any of the language. At this point of time, it's most use cases are using language as an English. They generate response based on the trained data they have seen, right? So any LLM product, so they can respond to you only on the trained data, right? So if you say, like, if you ask any question relevant about your university, right, it cannot answer. Irrelevant about your household work, it cannot answer. Relevant about your schedule, it cannot answer. So we want to see how can we use the LLM framework to answer your own, answering your own PDF, answering your own data set. That is RAG. I'll come to it. So basically, performance improves with the data size on LLM perspective and the model. The more bigger the model is, the more performance is. It's going to give you more a good performance. And of course, the LLM, right? As I mentioned earlier, it always have some kind of a pitfall, meaning LLMs are limited to the data they are trained on. They cannot answer anything out from the data they are trained on, right? And also the hallucination. Hallucination is the biggest problem in the LLM world, right? Sometimes it generate very plausible sounding, but the information will be totally incorrect. Sometimes it could say like, I mean, if you read that information, you feel like it is correct, but actually when you do the fact checking, it would be a totally incorrect one. That's a hallucination. It's still a problem with LLM. The workaround for that one is using RAG application. And lack of specificity, meaning the general purpose LLM may struggle to provide very precise answer. So the foundation model, what we have in place, cannot give you a very precise answer. It will be more generic one. So whatever I discussed there, right, the pitfalls here, like it's outdated knowledge, it can hallucinate, it cannot answer the specific question. All those things, whatever you face with your generic LLM model, it could be ChatGPT, it could be a Claude, it could be a Bedrock product, it could be a Microsoft product. All those models has this problem. All the foundation model, all this problem. How can we overcome it? Using a architecture called RAG. What is RAG? RAG is an retrieval augmented generation. It's an advanced method in AI, which basically what it does, it generate, it takes the content from your own local database and generate the context to the LLM and provide more information to the LLM in terms of context. So context, it will use the context as a training data and provide the information you want. So RAG combines two technologies. One is retrieval system for finding the relevant data, and a generative AI model, whatever you are using. So in essence, RAG has two primary components. One is your own data source or a knowledge source. Then, of course, a normal foundational model, whatever you use in a daily day-to-day life. How RAG solves the LLM limitation? As I mentioned, updated knowledge. RAG retrieves up-to-date information from the external source. The external source, as of today, it can be of anything. It can connect to a Google Drive. It can connect to your Confluence page. It can be a PDF. It can connect to a book. It can connect to any kind of live source. It can use that as a data source, and it can provide you the precise and exact information to you. So that's how it reduces the hallucination by grounding the response with the real-time data, right? It reduces the likelihood of incorrect answer because it's going to provide you the answer with the context what is already having or the source you are providing through a RAG architecture. And of course, RAG can be domain specific. RAG retrieves domain specific information, making it really useful for the specialized industries. Say like using a LLM plus RAG combination, you can make a pediatrician thing. You can make a attorney or a lawyer assistant. So today, what are we going to see? Like we're going to see like more of a motorbike assistant. So if you wanted to the black product, what we're going to develop at the end of the session, we're going to do a motorbike assistant. So it's going to help you out whatever the motorbike available in the market to choose in your shop and help the customer to choose what they want. So this is the step by step. So it first user provides the query. That's the query is provided question, whatever question user asks. Then the vectorization. The query is converted to a vector using embedding model. The embedding model of could be of anything. The standard embedding model usually the industry uses is GPT text thing. It's a very standard one, and of course a vector database, vector search. So if you think about it, you provide the user provides the query gets converted in the vector form, just the numbers, the user query converted in the number, then this number is stored into a vector database. In from the flow side, the query will be converted into a number, and the number will be searched as data in the vector database. And then the data retrieval. So the system fetches the relevant document based on the vector similarity, right? So think about this one. There are multiple vector similarity options are available behind the scene. The standard one usually the industry uses a cosine similarity. If you're just building a model, RAG application, just with the if you wanted to use PDF as a data source, say like if you have a book, 10 books with you, and if you wanted to do a search on that book, you wanted to use that book as your LLM source, you can use a simple cosine similarity vector search model. Response generation, the retrieved documents are passed into LLM, which generate like a human-like response. Of course, the final output is sent to the user. So this is the overview, as I mentioned. The user asks the query, and the queries are embedded, and the embedded queries are stored, searched in the vector store. This is the normal flow post building the vector data source, right? Before that, even before going to this loop, if you think about the second line item, the context, right? The context repo, if you can see here, this is your data source. So this is your PDF. This is your any kind of Confluence page. It could be your data source from the Google Drive, anything of nature, right? This is your. Let's stick with the basic example of a PDF. This PDF is chunk and embed and chunked means cut that into different paragraphs. So say like if you have a PDF of 10 pages, all the 10 pages from the 10 pages you can chunk that into a different uh, paragraph, then convert that into embedding. So the process is first chunking the PDF, then embedding like could we use any kind of embedding model, then store that in a vector store. This is your first step in the RAG process. If you see the argument, right, this is your first step in your RAG process. So when the user queries are again converted into embedding, and the embedding is search. Say like I have a book which talk about the networking. I have the networking book stored in this vector store. The PDF is converted into chunking. Then it is embedded. The embedding, as I mentioned, is a numerical representation of the actual natural language data. Is stored in the vector store. Right? I'm done with the vector store. Then on top of it, the first step of the RAG application, I'm repeating, it's a vector store, storing a data into vector store. Now, when a user says, "Hey, I want some information from that networking book," right? Then the whatever user query say, uh, talk me about TCP protocol. Give me information about the TCP protocol. If that is the question from the user, then that give me the information about the TCP protocol is converted into a numerical embedding. And that numerical embedding, the numerical value searched against the vector store. And say the vector store is it's a PDF data, right? So the TCP, give me a TCP data, relevant information about the TCP layer from the networking book. The vector search is going to search all the relevant information, and if you can see the relevant chunks are retrieved, then in the generate section, it given us a prompt template to the LLM. So this LLM is your foundation model, right? This foundation model could be of anything. You can use any model. It could be a GPT-4, it could be Claude, it could be uh, uh, Azure Copilot, anything of that nature. So still the foundation model is going to remain the same. This is the part that I mentioned. So the context, whatever you're going to generate from the vector store, it's going to give additional information to this LLM. Then the LLM could answer the more appropriate answer to you, and it returns the answer to this forum. That's how the RAG flow works. As I mentioned, the key component within the RAG model is find the relevant information from the external data source, like a database or a document. Then a Gen AI model, it's a foundational model, uses the information to create the human-like response in the natural language. And why combine retrieval and generation, right? So as I mentioned earlier, it's complement, and the core purpose it riches the response. Instead of generating the answer uh, based on solely on the model internal knowledge, RAG can include the actual fact about the information, the actual fact about your internal data, and could improve the accuracy of the result you get. And the information of the RAG could be dynamic. So the pipeline what we have in place in the current industry, in my current organization, we have a RAG pipeline build, which gets updated on daily basis, and the information is up to date, right? But if you think about the GPT models, the models from 3.5 is limited to, if I'm right, like I think it's November 2022 or 23, right? It took a lot of time for the GPT-4. It can offer you current information because it's searching from the web, but it cannot offer the information what you want from your internal data set. That's the beauty of the rack here. The key advantages of rack model, it access to the internal knowledge and scalability because it can handle vast amount of data, making it useful for the large organization to develop their own application, to develop their own model, RAG application model. So let's say like a new person joining the organization, right? A new person joining the university. If they wanted to know about, hey, how can I log in into the system, how can I reset the password, instead of going through the documentation, it can we if we have a RAG application built based on the documentation we have, you can just start with that application. It can provide you all the relevant information. So accuracy and precision are really, really improved a lot once you have the RAG application in place. So uh, how it really improves, like it generates answer based on the traditional language model can only answer based on the trained data, right? But the RAG can answer you with the real-time updated information because the vector store, however you maintain, that's all you have to do. You don't have to pre-train your entire large language model. As long as your context window has the information from the RAG vector database, as long as you have that updated information there, your LLM is always going to provide you the very good answer. Few applications within the using RAG, a research assistant. It's really this is really coming big. It's helping the academics to retrieve the latest research paper in healthcare, pulling the medical records, so research for diagnosis and treatment options, and customer service. RAG application is coming really big. It's providing the specific answer using FAQs or a database, and of course a legal assistant. So legal assistant is also catching up right now. As of today in US, if you have any questions, you have to set up a call with your attorney for 15 minutes of discussion. They are charging like closer to $400 to $500. But down the line, I'm pretty sure maybe in a year or so, we're going to have a GPT based RAG application, which going to serve as a legal assistant. Maybe of course they make claims saying it's not a proprietary advice, of course, but there's a good wide variety of applications going to become available because of this RAG. With the help of LLM, the foundation model and the RAG, we're going to have large number of applications. This is a few which I can come up on, which few which is already in place in the in the market. In summary, RAG models combines retrieval and the generation technologies. Um, it's very ideal for a situation where up-to-date and the relevant information is needed. It's applied across the industry, not just to a specific industry. I wanted to give some overview about the vector database as well. So as I mentioned, in the core component of the RAG application or a RAG framework is a vector database. So being an IT students, you guys should also already have a background about the normal database, right? Like a relational database, NoSQL database. It's kind of same. Sorry, I should not say it's kind of same, but the core context is same. Again, the database and table, everything is same, but the way the information is stored, that the type of information is stored is like in a vector form, right? Think about this one, right? In your college or a school, you could have studied something about the matrices, 3x3 matrices, 3x10 matrices. But now, right now, for the AI application, there are like a billions of combination of matrices. So that's how it's stored behind the scene. The documents, whatever you give, it could be a PDF or anything at all, is chunked and converted into the numerical representation and stored in the vector database. That is the vector database. So what is it? By definition, Database is a type of database. It stores and search data in forms of vector, to be clear, a matrix format, um, which is a numerical representation of a data. Could be of text, image, audio, or any kind of a video representation, multidimensional display in a multidimensional space. That is a vector database. The purpose of the vector database is designed to efficiently store and retrieve the high dimensional data. Think about this, right? Right now, what we see is the two-dimensional. You might have watched the movie in the three-dimensional, but in the vector, it's like a millions of dimension. Even for a very basic thing, you can go with 1,200 dimensions of data conversion, which is even available in the freely available in the market. So that's how the data will be passed and stored in the dimensional in the vector dimension in the vector database. Um, Key use case, anything on the RAG application is 100% vector database is needed, at least at this point of time. Used in applications such as a recommendation system, like image processing, any kind of a semantic search, whatever you use, it's 100% behind the scenes a vector database. How it differs from the traditional database? Traditional database stores the structured data like a number, string, and a varchar, and etc. Whereas the vector database stores embedding of vectors, which represents the complex data like a text, image, whatever things you can think of is the representation of that in a vector form. So this is how the vector database work. First thing, once you have data in place, first you have to do a embedding. So the raw text, raw data such as text, image, is transferred into a vector using a machine learning model. It could be of anything, say maybe a sentence transformer model or a bread. However, whatever model you want to use, those model converts that's how the conversion happens, right? Those model converts the document into a vector, and these vectors are stored in the vector database, right? Once converted into vector, the data is stored in vector database. Each vector represents some kind of a point in the multi-dimensional space. If you open the vector, you can see like point 1, point 3. You can see like at least 20 dimensions of data representing. You can actually query the vector database. If you query vector database, you can see the vector. What is the vector form for any natural language text? For example, like say like searching with a vector similarity, right? This text, if you open the vector database, it will be stored in the vector form, like a point 1, point 3, point 4, point 5. However dimension you define, this vector, this particular string or text will be converted into that number of dimension and stored in the vector database. And of course, when the vector database only knows the vector stuff. So once you store your knowledge source in the vector, if you remember the RAG pipeline which I mentioned, the user query, the natural language, again should be converted into a embedding. Embedding meaning again the numerical form. Then again this numerical form is queried to the vector database, and that's how. And we have a lot of options available to query the vector database. It could be a cosine similarity, that's a very standard one, and there is Euclid distance, and other popular methods are available. But if your use case is a simple PDF search, a text data, cosine similarity is more than good. As I mentioned earlier, semantic search, the example use cases for vector, like 100% for vector for RAG application, like a semantic search, recommendation engine, and any kind of image retrieval, you always need a vector database. Let's go a little deeper, as I mentioned. So this is an image, and you can use the image transformer as an embedding algorithm to convert this into a vector and store it into a vector database. This is how it would be. If it is text, you can use any kind of an NLP transformer and convert it into an embedding and store this in a vector database. Likewise, it could be of anything audio file. You can embed that using any kind of audio transformer, convert that into a vector and store it into a vector database. So that's kind of so critical. The knowledge with the vector database is so critical. I honestly, down the line, in 3 or 4 years, not even 3 or 4 years, maybe like in a year or so. If any person, especially with the IT background, wanted to find a job, it's kind of a must know technology. If you wanted to get your hands dirty with the Gen AI technology, if you wanted to showcase yourself in the market, in the industry, as a Gen AI engineer or any kind of AI engineer, the role, and you definitely have to have good hands-on experience with the vector database. It's kind of a must one. So in RAG model, vector database is key for retrieval when the query is provided. Systems look up the relevant information and look for the vector similarity. It's the same thing which I mentioned earlier, right? So there are popular vector database available, a Pinecone, a VV8, and Facebook AI similarity search. Pinecone offer one index free, and if you really wanted to do some kind of a project within the university, you guys can use a PG vector. Postgres vector is completely community version is completely free. You can There are a lot of documentation available. You can play around, and there are a lot of certification available in the vector database as well. So I would sincerely recommend students or anyone who wanted to get hold of a Gen AI application or LLM engineering. Vector database is kind of a must. Yeah, this is kind of already covered. As I mentioned, like we started with the what is LLM, then we covered the overview about the RAG, and we also covered the what is vector database. All these things can combine. The next evaluation, a person should know how to do the prompt engineering, right? So prompt engineering is another field which, especially in the student community, or anyone who wanted to do a research, anyone who wanted. I was just speaking to my brother, so he was working in NVIDIA, and he mentioned a use case of calling an API to getting the job done, right? I immediately suggested him, you don't have to write a complete API. You have a proper prompt build, and you can get all the things done for you by LLM. That's how powerful the prompt is. The prompt has a certain structure. You guys have, if you follow a proper of a structure in the prompt, you're going to get a real good information. I'm going to share you some tips and tricks there. So, what is prompt engineering? By definition, prompt engineering is a process of designing and developing and optimizing the prompt for LLM. The major importance is to ensure LLM provide more accurate and useful response by providing a very clear instruction. So there are different techniques available within the prompt engineering. To start with the zero-shot prompting, where you're not going to give you any example. You're just going to ask a very straightforward, blunt question. Hey, what is the capital of Vietnam? Right? A few short prompting, we're going to give a more guided question. And I'm going to give you examples, so don't worry. Chain of thought prompting, like you're going to give a step-by-step reasoning in the prompt, right? And of course, the instruction-based prompting. These are the few main methodologies within the prompting technique, which I would like to highlight. Then let me start with the zero-shot prompting. So as I mentioned, if you see here, by definition, no examples are provided here in the prompt. The model is expected to perform a task without prior guidance, right? For example, translate the following English sentence into French. I love exploring new cities. So the response, J. Ame Explorer D. Novelis Villas. So it's a very straightforward prompt, right? And this is called a zero shot prompting. The model is asked to perform the task without any example. Let's give some few examples on the few shot prompting. So here, the model is given few examples, like to guide how to perform the task. Example, task generate creative headlines for a tech news article, and you're also giving some kind of example, AI evolution, how machines are redefining the human potential. Here, if you see, you're giving the example, you're also asking the question or a task. Along with that, you're giving an example. So this gives a little better response compared to zero shot prompting, right? So the more you example you give to the prompt, in the to the LLM prompt, a better result you're going to get. That's the key takeaway here. And another thing is the chain of thought. So here, the model is encouraged to break down its reasoning process step by step, um, to arrive to an answer, right? For example, if a John has 10 apple and gives 4 to Sarah and then buys 5 more apple, how many apples does he have? Explain your reasoning. So you're asking thought provoking questions to the LLM model. But now I mean, with the advent of technology, right, with the advent of O3 models within the LLM, this is kind of becoming I wouldn't say an absolute. If you wanted to use your GPT-4 instead of going for a hardcore reasoning model, you can use this kind of prompting to make your a foundational GPT-4 model to act as a reasoning model. You can use this kind of a prompting, chain of thought prompting. And then instructional based prompting. Here, the prompt contains a detailed instruction guiding step by step. So, example, the prompt is summarize this article. You're exactly giving saying, hey, summarize this article in 3 sentences, focusing on main events but avoiding any opinion or personal insights, right? You're really giving instruction to it. So then the response is the article discusses the launch of a new smartphone by company X, and it highlights the phone features. It's really giving the precise information what you want. So that's the beauty of the prompt. The more you the proper prompt you ask, the proper question you ask to the LLM, you're going to get the defined answer however you are defining the prompt. If you want to give a very generic prompt, you're going to get a very generic answer to it. um, so let me give some additional information about the prompt engineering. So basically, there are 4 building blocks for a prompt. One is instruction, other one is context, other one is input data, other one is the output indicator, right? If you follow this prompt template, these blocks of prompting template to any of your LLM model, you're going to get a result you want. You have to make sure you follow this prompt when you are prompting to any of your LLM model, right? Um, let's start with some kind of example, right? Say, give me 2-day travel guide for Dallas, Texas. Right here, there's no. I'm from Dallas, Texas, so I just use that as a example. Give me 2 days travel guide for Dallas, Texas. So what it says, there is no instruction, no context, no specific attraction or recommendation you ask. The response is going to be like a day one, you just ask for 2 day. So it's going to give you day one, visit Dallas Zoo and go to Reunion Tower. Day two, go to Dallas World Aquarium, eat at BBQ place, right? This response is too basic. You're not going to use your entire LLM knowledge for it, right? Think about this one. If you give more, if you the same question, if you follow the prompt with the prompt with the base 4 building blocks, example, the instruction: create a 2-day travel itinerary for a Dallas, focusing on cultural landmark, museum, and local dining spot. And the context you're going to give here, a trip. The trip is for a first-time visitor, and make sure it's a family-friendly. Include hidden gems. And input data you're giving here, include Dallas Museum Art, sixth floor museum, whatever the future place you wanted to visit, right? And you're also giving the output indicator, a list the activities for a morning and afternoon with the meal suggestion. So this prompt, we're going to let's see how the response will be. The response is so detailed, right? It says morning, Dallas Museum of Art, start your day with exploring. Then afternoon, sixth floor museum, and day two morning do this one. Day afternoon do this one. And if you can see, it also gives you uh, the lunch option. The morning after for lunch you go to this place, and dinner go to this place. Especially the same thing. It says the kids friendly, and it says it has kids friendly menu and stuff, right? So that's how we have to play around with the prompt. So the reason I'm trying to explain this one, anything with the RAG application, anything with the LLM architecture, your entire application is built on the prompt. The more the rigorous prompt you give, the more accurate prompt you work on, the more accurate output you're going to get. If you don't give the proper prompt in your in the LLM application, how complex architecture you define, how complex vector database, how efficient vector database you use, how many millions dollar you spend. If you don't have the proper prompt for a LLM application, for a RAG application, you're not going to get any the concrete answer you're looking for. Okay. Some key parameter also I wanted to highlight. So temperature, top P and top K. These parameters for LLM model and the RAG application is especially available only if you use any kind of a API driven LLM, meaning say if you are using your day to day activity, if you log into a chat GPT, you cannot use this parameter, temperature, top P, top period. But if you are developing an application using a GPT-4 and you have an API access, in that API access, you can provide these key parameters in the temperature and stuff, right? So what is temperature? Um, so temperature controls the creativity of the response, how well the response is going to be, and top P limits the selection of words based on the probability, right? And likewise, the top K limits the number of possible words considered for these generation steps. Let's see some example, right? In the prompt, you're asking, write a short description of Eiffel Tower, and you're setting the temperature of zero point 0.2. What it says to this LLM model, don't be creative, right? And you're selling a top P of 0.25. What you're telling to the LLM model, select top 25% of most likely words, right? Likewise, you're setting the top P of 10, consider top 10 most likely words. So you're telling the LLM model, don't be creative, just use top 25% word, don't go beyond that. And you're telling the LLM model, give me a probability which is top 10 word could be used on that particular response. So the response is very straightforward. Eiffel Tower is a frame. If you see the response, it says Eiffel Tower is a famous science structure in Paris, France. It was completed in 1889 and it stands at 324-meter falls, right? This is very generic answer, because why? You're setting at the temperature of zero point 0.2 and you have 0.25 and 10. Let's see the same question was with the different temperature setting. When you set the temperature setting of 1, your LLM response is going to give you like a top, like a poetic person. You say if the same question, the same prompt, let's see how the answer would differ if you're going to use a temperature of 1, top P of 0.99, and the top K of 500. If you see the response, it's a Eiffel Tower stretches its iron arms into the sky like a metallic giant watching over the city of Paris. So it's like a poet right now. So you can see the creativity of the response from the LLM, right? How creative it has become just by adjusting this parameter. There are billions of parameters available within the LLM, but in your most use cases, if you can play around with this 3 primary parameter, it's going to you're good enough to develop any kind of a LLM application. And we saw two examples. One is a lower temperature, another is an extreme. Let's see. But the ideal use case to have, depending on the use case, again, there is no ideal use case. Usually, if you have a temperature of less than 0.5, it should be good. 0.7, zero point 0.8, and top P of 0.8 and top K of 50 words, right? The same answer here. Eiffel Tower is an iconic symbol of Paris, built in 1899 for the World Fair, standing at the over 300-meter tall, right? So you can see the difference. The reason I'm covering all these things within the RAG application, your application all depends on how well you do a prompt engineering, right? That's why I wanted to make sure explicitly cover all those stuff when you really develop any RAG application. So there's also another thing called a negative prompting, which means explicitly telling not to do this, right? Example, avoid discussing technical configuration or avoid discussing any racial data. So you can tell the LLM response, hey, don't give this information, or avoid responding to any profane questions. So you can tell the LLM response when you develop an RAG application, so that user cannot hack your RAG application. So if they ask some questions which is inappropriate, If you have a negative prompting, say don't answer any inappropriate questions, example so and so, it won't trust for your application cannot be broken. Your application going to be so smart to it. Key takeaways: um, mastering prompt engineering enhances your LLM effectiveness, and using techniques like a negative prompting, a few shot prompting, and RAG improves the accuracy and um, uh, reduces the hallucination. Now, coming to the key part, the last part of the process of the session, I want to showcase how to actually build the RAG application within the Snowflake environment, right? Um, Give me 1 minute. So I'm not going to worry about what is Snowflake and stuff in this session. If you guys really want to know about the Snowflake, Snowflake does offer the academia solution, especially for the universities. It is completely free. If you guys want, please reach me out. I can help you to connect to the Snowflake folks to get yourself onboarded. They are providing like 1,300 credits. I just helped Indiana University of Pennsylvania to get themselves onboarded with the Snowflake, and they are just done with the undergrad program. I'm now trying to help them the graduate program. So this is a very good data cloud platform. Um, if you guys really interested, tell me. There's a lot of 100% free um, credits they are providing, and with the certification and help, I can help you guys to onboard. But this particular session is focused on RAG, so I'm going to stick with that one. So if you guys remember on the first flow architecture, right, creating a vector database and creating the vector store of information. So first we are starting with the, you know what, I can yeah, I can sure. So what I made sure to give me 1 minute. I'm trying to pull that one. Okay, let me show. Let me start with this one. So basically, what you're going to try first, you're going to create a service called a Cortex Search Service. This is a service which will help you to, if you guys remember, I mentioned the chunking the document, right? Any document you upload, it's help you to chunk the database. Give me 1 minute. Uh, yeah, sure. I'll share that PPT. You guys going to get the PPT for yeah, yeah. Yes. So I just want to make sure like it's already available so that you guys can learn and do stuff here. So the document link is already available, which I pinged to this chat. I can even share this PPT, the quick start guide. Um, so let let me give some quick overview. This is how the chatbot is going to be. This is a RAG application we are building right now. Basically, you're going to provide a bunch of, say, like you're owning a shop, right? The shop has information about you are owning a bike shop where you sell all kind of bike, ski and children bike, ski boots, and the roadside bike, uh, the premium bike available, all type of bike you're selling, right? You are trying to create a chatbot for that one. So that's the agenda here. And first you have to, the first thing you have to do, you have to make sure you have to create a database. Being so, as I mentioned, a vector database is needed to be created, but don't worry about that right now. Just to you're not going to learn everything in an hour, but the essence what I'm trying to cover here, you get to know the high level information so that you can Google and rewatch the video or go through the material one more time, and you can get things done, right? The first step, you're going to create the database. Then you're going to create the stage environment. Stage meaning you need some placeholder for the Snowflake to upload the file, right? The PDF file, whatever you are looking for. So as I mentioned, the PDF file, right? Infant bike detail, user guide, and everything, right? Then you're going to pre-process the document. So the pre-processed document. So this is how you're going to create a table to load all the documents information. First, you're creating a stage environment within the Snowflake where you're uploading the document. Then you're creating another environment or a table where you're just trying to create the chunk of the a table. So you're creating a table to chunk it. Then you're chunking the index and storing it. Don't worry about it. You This documentation which I pinged you is completely free, and anyone with a student ID can get yourself onboarded. All you have to do, just follow through this document, run this step by step. You can build your RAG application in an hour, right? Again, you are trying to chunk the information. Now try to correlate things with whatever I explained in the previous slide. You have the till the part which I dragged before. You have a PDF document. Now you're trying to chunk the PDF document. The chunking part is done. So now if you can see, the PDF document is available. Now we are trying to chunk it, right? Then you're creating a Cortex search service. This is where the vector database is enabled. So on top of the chunked data, so if you see, you can see here, the PDF document is chunked into a table. Then we are creating a vector database for that chunked table, right? Then you're creating a Streamlit app. Streamlit is a UI for your data. So like until 3 or a couple of years before, right? The way the industry work, anything on a UI is a front-end developer work, right? The back-end developer or a data engineer or a data warehousing person cannot have any kind of a UI build for data. So the once like couple of years before, the open source version called Streamlit came into queue, Streamlit came into picture. So where anyone with a basic Python knowledge can develop an app or develop a front-end UI on top of your data. That's how powerful it is. I'm going to show you, just I want to give the overview. This is the code um, on how to build this one. So whatever I explained in the previous slides, the step-by-step process, right, is covered in this code. So if you remember, I spent a lot of amount of time on prompt engineering, right? So this is where you have to give the exact prompt. You're telling if you see here, I'm telling this chatbot, you are an expert chat assistant that extracts information from the context provided between the context and the context tag. When answering the questions contained between the tag, be concise, do not hallucinate. And if you don't have the information, just say only answer the question you can extract it from the context. So what I'm explicitly saying, hey, don't answer from your general knowledge or the knowledge which you're trained on. Give me the answer from the PDF which I uploaded. Give me the answer from the vector store which I created. Just give me that answer alone. Because I don't want to know. So think about this one, right? If I want a store, if I want any kind of a grocery store, could be of anything. I don't want the LLM to answer about my product with the general knowledge. It has to answer what product I have, what's the price of the product I have. So it has to say, if it doesn't have, it has to say it doesn't have that information. I'm explicitly telling, do not mention the context. Only answer the question if you can extract it from the context provided. Here, the context, what I mean, the PDF document. Then it's just a simple application. If you can see, hardly like a 200 lines of code. will help you to generate this application in no time, right? Uh, in just for a time perspective, right? I already built this application in the Snowflake as a Streamlit app. As you can see here, this is the thing which I built. The complete code, entire end-to-end code, is available in this quick start guide, Snowflake quick start guide, which I pinged in this chapter now, right? You guys can just create the login information within the Snowflake, and if you guys can run through the entire end-to-end code mentioned in this document, you should able to create the your own chatbot in a matter of hours, right? Let's see. So I followed all the steps which I mentioned. So this is the chatbot which I created using the instruction which I shown there. So I'm going to ask, um, give me uh, information about infant bike. So we can see oh, sorry, I'm sorry. Maybe then I should go. Let me. So using this is a chatbot which is built, the code which I already shared, on the process which I already shared. If you can see the question which I asked to the chatbot, give me information about the infant bike. Now it says infant bikes, also known as a balance bike or toddler bike, designed for very young children. It also says the key features and the benefit of it and the type of infant bike and choosing the right infant bike. It gives a lot of information. Now, let me ask, give me details about Toyota car. Let's see what it says. I use very small engines, that's why it's taking time. Usually, just for a demo purpose, but it can answer better. Um, Hold on, model. Sorry, sorry. Yeah. If you can see, it says, give me details about Toyota car. It says, I don't have any information. So in the application, it has two options. One is to use the just a document. Let's not go there. So um, uh, now if you can see, it says I don't have this information. Why? Because this particular RAG application is built on the data source, our own data source, right? Uh, think about this one. It's your own book. Now it's not hallucinating. It's not giving any information outside the context. You're using the model which I'm using right now, Mistral Large 2. That's the foundation model, and the data source I'm using is from for my shop, right? This could be of your university information. This could be of a pediatric information. This could be of any legal assistant, right? You're going to make your own data set to answer question, do a chatbot, develop a chatbot for your own data source using this RAG application, right? If I ask the same question to the LLM model using ChatGPT, it may definitely go and answer, but I don't have this information in my RAG store. That's why it's not answering me. I don't want my internal employees or internal university people to use this tool for answering any random question. For that, they can use their own LLM model. But here, the use cases are endless. You can think about anything. You can think about any use case, any document. You can build on the fly and get the information. You can make your own chatbot in a matter of hours. Yeah. I hope I covered everything which I intended to cover. I'm open for Q&A. I think we are left with 4 more minutes. Or if you guys want more detail on any specific topic or a specific question, I'm more than happy to help.
Thank you very much, Vinos. So thank you very much for your interesting presentation. And now the time for questions and answering, right? So any question? Okay, Phan Anh. Okay, please feel free to ask him.
Yes. Hello, Professor. My name is Tung. And want to ask about if I want to build a law document, which is essential to have a law name or law number, a section article or clickable link URL. How can I do that? Since I only see the rack only retrieve a plain text document, not a clickable link or an additional section, since the PDF don't have that information.
Very good question. Um, a- all these things can be controlled within the prompt, right? In the prompt, you can say, "Hey, give me the source of the data set as well, source of your information as well." It will provide you the information. It's that simple. You all you have to say in the prompt, "Hey, when you provide the answer, give the URL or from where you have taken this information." That's all you have to do. Did I answer your question, Pan? And by the way, I'm not professor. I'm an industry person. So sorry.
My bad.
Yeah. No.
Yes. Okay. Because the input I think of is a local document file, so it won't have a href or a clickable link, which is we have to manually add in. So how can we do that?
So your question, you wanted to give a manual link for it. Good question. So I mean, if you wanted to have drive the user externally, you can have some kind of a metadata, a different table. It doesn't have to be a rack table. So you have to, the architecture is a very good question, and it's a bit complex, not complex, a bit additional process should be involved. So when the user queries, right, you have to determine what type of a query it is. You have to make an LLM call and decide whether this particular query need any kind of a URL that need to be sent back to the user. If it is yes, send the URL as a context along with the rack context, then ask question to the LLM. Your architecture flow should be get the user query, hit the LLM model, and ask the LLM model to determine whether whether this user query need any kind of a URL, right? All those URL information you need to store that in a separate metadata table, normal database, right? Standard relational database. Take that information, then go to the rack, get the relevant information. When I say rack, the vector database, take the context from the your normal database where you have the URL, and then to the rack vector data store, then go call your LLM. Then by that way, when you respond to the user, you can provide all the three. But honestly, now the things have become so advanced on your vector database. You can also store other relational column detail as well, other relation metadata as well. You can design a process in the same vector database. You can store your normal URL as well, so that we can give the response from your LLM. Did I answer your question, Pan?
Yes, thank you very much. Your answer very clear.
Sure. I mean, I'm available in ADP list if you really want to, work about the architecture. You can schedule a call. More than happy to help you out. Yes. I think I have another question.
Please, Kim
Yeah.
Anh.
Yeah, thank you, Professor, for the presentation today. Uh, I'm wondering, in the the use case of this Rush LM model before, because we see that in the model we need the core LLM model, and I'm thinking of, okay, so for example, we are at the institution, we going to do research, and we want to build an LLM model and not build a RAS or continuous learning further also. because it's not on the time the users had to put many resources in the contest, etc. We want to build a chatbot for industry, for them, example, for education, for psychology, or for medical health, for example. So if you have any experience with the purchase, for example, the cost, the management for the to build an open LLM, and then okay, depend on the context, we can have the RAS LM model and how to deal with the data and management everything with the low cost. Thank you.
Good, very good question, right? So, couple of things. If you're really looking for the university purpose, there are a lot of products available in the market. They are making it free for university. You can do a research, you can do a POC and stuff. One such thing is a Snowflake. They provide 1,500 credit where you can explore for every semester. You can do a lot of research project on that. It's completely free. I can help you guys to onboard. You can touch base. I can help you guys onboard there. Uh, on cost and on the performance issues and the cost, right? So the couple of things we have. So if you go by API calls, meaning if you call your LLM model, say like if you are calling ChatGPT, right, the GPT-4 model, 4.0 model through an API, right, you're going to pay a lot of cost for it, and it's going to be super complex. So, and there are let me ping you to this. Give me one second. Um, so think about this as I'm just pinging to this group. Hugging Face is this particular thing. I think most of you should already know if you're trying to explore an LLM. This is something like a Play Store or App Store in your Apple, where you have a lot of models available, right? If you're really concerned with the cost, all you have to do with the especially on the LLM cost, there are a lot of models available from this forum. You can download the full version. Could be of 8 GB to 200 GB models are available. You can download on your local environment. You can download in your cloud application. You can call it directly instead of making the API call. That's how we can save the cost. And also the context window, right? But if you really, there are context window depending on the use case, right? The psychology full book, if you wanted to do, you have to have a proper chunking methodology in place. You don't need a complete context window, right? There are a lot of, I mean, models like even a 10 GB models can help you out, but you need to have a proper chunking. You have to chunk the document and store the vectorized data so that it can answer. So you need to have proper context. You need to have your RAG application built to have a context in place so that it stores the memory and retrieves the overall information. I don't know whether I answered your question. I hope, ma'am.
Uh, yeah, thank you. Sorry, I have another question. Yeah,
Sure, sure. Thank
because the further on, I'm thinking of RAS features in the context and how we can update the LLM models in terms of continuous learning for the model. And at the same time, we're thinking of, okay, privacy, data, control of the user. For example, if we continue in learning the model, it means the input data prompt, whatever the files, the prompt information they put inside, we can learn and we build up an updated LLM model. But if RAS, depending on the context, we can lock. Is it right? If I'm understanding?
So,
It,
um, it's yes and no.
no.
So,
Yeah.
I mean, it's depending on the use case, right?
Yeah.
So RAG, you don't. I mean, you still need a basic foundation model, right? For continuous learning, there are few use cases where you really need to retrain the model. The RAG may not be 100% solution for that. But 99% of the use case, if say like if you wanted to make your model to behave completely like a doctor or a legal paralegal person, You can it's kind of a test and trail and test, right? If you use a RAG, you may get 99% accurate information because you don't have to retrain the model. You're going to have the same old foundational model. It could be a 4.0 or 3.5, right? Keep your RAG process updated. You can keep the RAG data updated. You don't have to retrain the complete model. Yeah, to answer the question, is true. You don't have to. You can have the old model. You can keep the RAG application updated regularly so that you have the up-to-date information and use that as a context and call your LLM model. You don't have to retrain the model. You can still have GPT 3.5, which was like built a year before. You can get the current real-time information using a RAG architecture, right? But my point, yes, we can do that, but there are few niche use cases. If you really wanted to build a complete enterprise application, maybe retraining may be a better option, right? Depending on the use case. But if you don't have a heavy pull, you can use a RAG architecture where you can use a old foundational model, keep your RAG to up to date, and use that as a context and call your LLM to retrieve the information.
Yeah, thank you.
Sure. Yeah. Any other question?
Yeah, I have one question.
Yes.
So I'm considering about the prompt engineering you use for RAG. So my question is whether is there any difference between using prompt in the normal use and in RAG system? Is there any difference?
Not normal in the sense, Professor.
I mean that you use the prompt technique, right, for RAG
Uh-huh.
system. But
Yeah.
my considering is about whether the using a prompt technique in normal use, normal case, is different from using in RAG system.
Oh, got it. Got it. Very good question. Very good question. Yeah.
Mhm,
So, I mean, uh, the major reason for the prompt, right? You are instructing the LLM to give the answer you want. It
mhm,
still remains the same.
mhm,
So, even in the RAG application, if you remember the architecture or the flow diagram which I mentioned, you're going to get the context. You're going to get the real-time information from the RAG or a vector database, and you're
mhm.
going to give the context to the LLM, call the LLM, right? So the prompt you're tuning, the prompt you're working on it, you're still telling the final output. You're still telling to the foundational model along with the context. So the prompt engineering still you're talking with your LLM model, not with a RAG. RAG provides additional context, the context information, additional information to the prompt, and you're controlling the user output, the output from the entire application through a prompt. So the prompt is a separate entity. You're going to control the LLM model, not the RAG. But if you take a step back and look into it, you're in turn you're controlling the entire application, but you're not controlling the RAG per se, the RAG part of your RAG application, the vector database part of your application. You're not prompting there. You're still prompting the foundational model. You're still prompting how the output should be within the foundational model. You're adding the context from the RAG. You're adding the context to the LLM. So let me quickly go through the pipeline, right? So what you're doing first, user queries, then do the user query is embedded, then goes to the RAG application or a vector database. For the user query, whatever is provided, we're going to hit the RAG and we're going to retrieve the information. That retrieved information, the current real-time information, you're going to call your LLM model. Till now, you haven't called. User query
Uh,
goes to.
of course, I know that the prompt technique is the same for every task, but we need the different strategy for the specific task. So, for example, so I know that when we have a question, so sometimes we need to rewrite the question. Yeah. So I mean that when you rewrite the question to expand the information of the question, and then you can match to the corresponding chunk in the local database. So we have to prompt to expand the question. So I mean that we need a, a specialized or specific prompting strategy when we doing with the RAG system. Yeah, do you understand my question? Yeah,
Yeah.
I just consider about that. Yeah.
No, yeah, it's not specific with the rack system. Rack system per se is specific to the application we are developing, use case we are developing. If you are developing for a credit card information, right? Then the prompt would be a bit different. If you are developing for a medical use case, right? Then the prompt would be quite different. If you are developing for an educational use case, then the prompting would be a bit different. But whatever prompt you're doing, you're not specifically doing for the RAG flow per se. But if you take a step backward and see, it may look like you're writing a prompt for the RAG, but you are writing a prompt for LLM model, the final step, the context window.
We need some more discussion. I from your experience in developing RAG system, whether you use the prompt for generation or only, or you use a prompt technique also in the retrieval process, whether you use a prompt in the retrieval step.
No, I don't think so. You can use in the retrieval. It may not be useful because you. I mean,
So
of course.
in the RAG system, you use a prompting only in the generation step, right?
Yes.
Oh, okay. So now, because
Yes.
from my experience when doing with project with my student, they use a prompt for the reachable step, and so they can extend the query, and then they build the embedding vector from the extended question, and then they can matching with the chunk in the local database. Okay, so
Yeah.
maybe it's useful.
I don't think so because you want to have all the information retrieved first, right? Then you let the generation step to decide what is not needed, what is needed.
Okay.
Um, I mean, that's a typical industry standard. I wouldn't recommend having the prompt for the retrieval process, but again, it I have to go through the architecture and see why it is needed. In the generic, in the industry use case, the prompt will be on the generation side to
Yeah,
answer your
that's
question.
important in the generation step.
Yeah,
Okay,
yeah.
I know. Okay,
Because
thank
we
you.
need all the information right before taking the decision. We need all kind of information. But if it is creating a performance issues, I mean, you can design the architecture however you want, but the industry standard have the prompt in the generation section.
Okay, thank you. Is any other question for Robinot? Okay, so no question anymore. So thank you very much, Professor Vinod. So I hope that you
Yeah,
can give another presentation for us in the future. Yeah. Okay,
sure. Sir. Yeah, 100%. Yeah. I need to take a
sure.
screenshot. You guys are okay? 1 minute.
Yes.
Uh, yeah.
Okay.
Yeah. Thank you, sir. Thank you for the opportunity. And also wanted to share. I'm available in this forum. I don't know whether you guys know about um, ADP list. If you guys need any hover, give me 1 minute.
Okay. So could you please send us those slides so that we can get your contact?
Yeah, I can send you the slide, Professor. Yeah, thank you. Yeah, I'm available in this forum. If you guys need any hour, you can. It's completely free forum. If you need any suggestion or questions, I'm more than happy to onboard and help you guys. Thank you.
Okay, thank you very much. Thank you very much, Professor. Okay, thank
Thank
you,
you.
everyone. Okay, thank you, everyone. So we stop here. Okay, see
Thank you.
you.
Bye.
Thank you.